Good morning, good afternoon, and good evening. Thank you all for joining me today for another advanced webinar series. Today we'll be learning about asynchronous processes on Salesforce platform, the what, the why, and the how. So before getting started into the weeds of the webinar and the presentation, so this is like the most famous slide of the webinar, and if you have been in any of the webinars in the past, you know what it is. It's a forward-looking statement. So in a nutshell, what this means is please do not make any buying decisions based on today's webinar. I might be speaking about the new functionality. Please do not consider those as your decisions to buy the stocks or anything on the Salesforce side. A little bit about ourselves. I'm Karthik Vishwanatha, Salesforce MVP, the Director of Development at TopFocus Inc. And you can follow me on my Twitter handle, log on to Karthik. And with me is MJ Khan, who is the Vice President of Development at TopFocus. And a little bit about our company. We are a Salesforce code consulting partner. We provide CRM consulting, project management, and custom software development to companies looking to improve their businesses. And we have expertise in all areas from ranging from Wave to Steelbreak to Salesforce. Few housekeeping things. Salesforce is social. So you can follow Salesforce on various social channels like Twitter, Facebook, LinkedIn, and YouTube. And you can get all the latest and greatest that's happening around in the Salesforce development site, development world, all the updates. And for your information, this webinar is being recorded, and you'll be getting a recorded link within a week or so that you can refer to it in the future for your reference. So today's agenda is divided into three parts. As I said in the beginning, the what, the why, and the how. I will be covering the what and the why, and the more interesting part and the demos, the how will be covered by MJ. To give you, so we will be covering a wide breadth of concepts in this webinar, and it will be a fast-paced webinar as well. And it gives everyone an idea of what asynchronous processes are in general, the types of asynchronous processes that you can invoke on Salesforce, the advantages and the disadvantages. So after this webinar, you should be having a very good idea and understanding of what this is, and you can get back to your desk and start working on these processes and comparing them. So what are the prerequisites for this webinar? The prerequisite, there is a prerequisite. So you have to have some good understanding of Apex programming on the Salesforce platform and a passion to learn the platform as well. So if you are new to the Salesforce world and on the programming world, I would definitely suggest you to go to trailhead.salesforce.com and start looking at some of the basic Trailhead modules, or go through some of the force.com Friday webinars that cover the basic concepts on the platform. So now let's get into the actual content. The what. What is asynchronous process? Any process that operates on its own without blocking the other processes is an asynchronous process. That's a one-line definition, and in the slide you can see in computer programs, asynchronous operation means the process that operates independently of other processes. And you can also see on the diagram there is a difference. I put in two different slides. One is synchronous and asynchronous. And in the synchronous, you can see a process A is invoking a process B and waiting for the response. So there is a wait time. Versus the synchronous, process A invokes, process B continues its own work, and it gets the response. When it gets the response from process B, it does whatever it needs to do. Some of the examples of the synchronous processes, especially in the programming world, JavaScript's AJAX model is a great example of the synchronous process, where the requests are passed on to the server and without impacting the current state of the page. If you look at maybe an airline search website, you're searching on airlines like Kayak or any other website. You enter in the source and the destination, the time you want to travel. What happens is the airline search will return you the results. The results are painted on the page dynamically, so it might return first 3 results and then it is searching for some more results. But it is not blocking you to do any actions on the page. So you can click on the results that came out, or you can click on something else on the page. So you can continue doing your work. So that is an example of a asynchronous process. There are so many examples in the real world on the internet, you can find in the synchronous process, but it is something that you need to understand exactly what this means. On to the next slide. So now that you know what an asynchronous process is, let's look at some of the differences between asynchronous and synchronous processes. The first difference is actions that will not block the transaction, as the definition says, versus the synchronous is a quick and immediate actions, so it blocks it. I mean, so it's almost immediate. Duration is not a priority in the synchronous, so we are really not worried about like how much time it's going to take for you to get the response back. Versus in the synchronous, it has to be immediate, fast, and serial. And the last thing, which is very specific to the Salesforce platform, is higher governor limits. So if you are familiar with what governor limits are, then you know what is meant by higher governor limits. So platform has a set of limitations on each of the things that you can do, and with the asynchronous processes, those you have higher limitations on those restrictions. Versus the synchronous process, it's all normal. So if you have like maybe 100 DML operations, you still can do only 100. So there is no higher value for that. So after looking at the differences, so the next few slides, I'm going to talk about how the processes are functioning with respect to the platform, what's happening behind the scenes. These concepts might not impact or teach you how to code on the synchronous processes, but they'll give you a strong understanding of what's happening behind the scenes. And as a programmer or as a developer or as an architect, it is important for you to go to that next level to understand what's happening. What this diagram says is that the way the Salesforce processes the synchronous requests is, it collects all the requests from various orgs, it puts it in a synchronous queue or a queue store, and then it takes the requests from those queue store and then passes to the application service for more processing. So this framework is called as queue-based framework. A queue-based framework is where all the requests are queued, waiting for their turn. And when the turn comes, the worker threads identify the places where they can be processed. So the classic example is, so if you have been traveling a lot, so if you go to a different country, there is an immigration process where you'll be standing in a queue and you'll have various immigration counters, and immigration officers will be sitting in those counters. You'll stand in a queue, and a person who will be roaming around will take you from the queue, and he will put you in a respective counter where the actual processing is done. So in this example, there are three things that are happening from the software side: is enqueue, persist, and dequeue. Enqueue is the process where the requests are queued. Persist is a process where a request is saved. And dequeue is the process where a request is pulled out from the queue. So enqueue and dequeue are pretty self-explanatory. The persist is something that I want to focus on. Is like the reason why we do persist is because during this whole processing, even though it's happening within like seconds or milliseconds, there is a possibility that the transaction might be lost because of some unknown reasons. So you need to always have the ability to restore it. So that's why you have this persist layer, where as soon as you enqueue your request from multiple organizations into this queue, make sure that Salesforce makes sure that it gets saved or persisted so that it can be restored in case of any issues. So let's look at some more concepts in more detail. So I was talking about the immigration example, right? So it's let's use the same analogy to this queue-based framework as well. So you have handlers, you have worker threads. I'm going to get into the flow control in detail, but you have peak set and delayed and extended delays. As I said, when you are in a queue, a worker thread, in the immigration example, a person takes you from the queue and puts it in front of an immigration counter. The same way, a worker thread takes the request from the queue and gives it to the handler, where the actual processing is happening. A handler can perform any kind of request from a given instance. For example, the synchronous processes have the requests like future, batch, queueable. So these kind of requests can be processed by a handler. So handler can do those, and worker threads are the ones that are responsible to hand over those requests to the handlers. And there is always a limitation because it is software, it is driven by its own limitations. So there is limitations to process these kind of things. So there is a finite set of worker threads that can be processed, finite set of handlers that can be processed at a given point of time. And in order to make sure that all the resources are effectively utilized against different organizations, Salesforce, the queue-based framework, implements something called as a flow control, where it controls the request from a single organization. So you cannot have like 10,000 requests coming from one single instance be processed at the same time. So what it does is it puts a check or a threshold, and then it allows the other organizations also to process their own requests. So we'll see that in the coming examples. And this concept is called multi-tenant fair share handling. As the definition says, because we are running in the multi-tenant environment where like there are multiple tenants or multiple orgs that are running, we are making sure that Salesforce is providing the same amount of resources for all these different organizations. And I'll also talk about what delay is. So let's look at a use case or a scenario. Organization 1 creates 13 future requests that are at the head and adjacent in the queue. So which looks like this picture where you have 13 requests from one single organization that are present in the queue. And then organization 2 adds 2 more future requests to the queue. So the queue looks like this. So you have all the ones in the green are from the org 1. All the 2 that are at the end of the queue are from the org 2. And then organization 1 again adds 2 more requests. So this is how the queue looks like. So everything is happening really quickly. So after end of these 3 scenarios, you can see that the queue looks like 13 requests from org 1, 2 requests from org 2, and again 2 requests from org 1. So let's go to the another scenario. So we have let's put some thresholds to it. So we have a maximum of 12 threads that can be processed per org. We have a peak set size of 15. That means like a full size that can be done, and there are 13 threads that are available. So if you look at this scenario, if you are not implementing the concept of control or flow control, what happens is organization 1 gets all the resources. It gets all the resources, and organization 2 is in a waiting state. So what it does is, first step, all the 12 threads are taken from org 1 and are processed. So it processes all the 12 threads from org 1. Second step, the 13th thread will be skipped because of flow control. So what it does is, okay, the 12 threads that are the max, it's done. So if the 13th thread is also from the org 1, it knows that it already processed 12. So it skips the 13th one and it processes it in the next round. So this is called delay. The delay is the process where a thread is skipped from a single organization because of the flow control. And then peak set, what it will do is within the peak set, which is like the total of 15 in the queue, it scans to see if there are any requests from other orgs. And in our case, it will find the request from the org 2, and it will process the ones from the org 2. So that's multi-tenant fair share handling, and there is a concept of delay. What happens when a particular organization requests occupy the entire peak set when the queue is scanned in the step 3 in the previous slide? So let's go back to the previous slide. So in the step 3, we are finding the ones from the org 2. What happens if there is nothing in the org 2 and if all the 15 are occupied by org 1 itself? So the queue-based framework, what it's going to do is it's going to take all the 15 and it's going to put everything to the back of the queue with an extended delay. That means it sets a timer or a sleep, it's like a sleep timer. It sets a timer on all these requests, and then it says that, okay, I'm not going to process any more requests from this queue one for next 10 minutes or 5 minutes or 15 minutes. So whatever the timer that is defined. and then it will continue processing the request from like the other organizations. So that is what an extended delay is. And when the requests are eligible for processing, and it's possible that the flow control will take this request and then again process it. If not, it will keep on putting it on the delay. So if like org1 is trying to like push in all these requests into the queue, and if there is nothing else coming into the queue, what it does is flow control, a queue-based framework will make sure that it puts on keeping it onto the delay. So it might add up to the extended delay. So that's how the multi-tenant fair share handling is done, and the queue-based framework works behind the scenes from the synchronous processes perspective. So let's go and look at. So we know what is asynchronous processes and what is happening behind the scenes. So let's go and look at the why. So the why is one that's focusing on why we need asynchronous processes. There are benefits. These are general benefits, not specific to the platform itself, but user efficiency, resource efficiency, scalability, fairness of processing, and transactional capabilities. Very self-explanatory. So you can say that with the user efficiency, you're not asking the user to wait for the process to finish, or you're not holding up the resources, or you're with the scalability, you can perform more actions behind the scenes versus having it happen real time. And fairness of processing primarily on the multi-tenant architecture, or where like you have multiple orgs working on making sure that all the orgs get the same amount of resources and getting good transactional capabilities. So these are all the different benefits. But let's look at why exactly these are needed on the Salesforce. So, well, you are familiar with the Salesforce, and you are all developers, so we are all programmers. So we need to know why exactly these are needed when we are actually coding or developing. So that's when these are different types of uses. The primary is avoiding governor limits. That's like the first and the foremost use. So if you are working on some kind of a process or a business logic where you are hitting the governor limits, asynchronous processes is the way. And the mixed DML operations, if you know what a mixed DML operation is, like you're trying to insert a setup and a non-setup object. Like setup objects are like user objects or like the queue objects, versus the non-setup are like the regular account contact objects. If you're trying to do both of them in the same transaction, it will fail. So making it asynchronous will help you create two different transactions, and it will allow you to process those setup and non-setup. And then definitely long-running user operations, making sure that putting them in asynchronous will help you out. And some of the real-time use cases are sending data to external systems via callouts, complex calculations like doing rollups on lookup fields or lookup objects, and report runs if there are any report runs that you want to trigger through Apex asynchronously using the report runs. And there are many other use cases. I mean, sky's the limit. You can think of multiple use cases. But these are some of the most common use cases. And the last use case before jumping on to the how is like bulk load API. The reason why I have this slide separate is because all the stuff that I've talked about is on the platform, that you built it on the platform, on the Salesforce platform, versus the bulk load API or bulk API, it is being triggered from outside of the platform. So an external system that is trying to load the data into Salesforce uses bulk API to upload the data faster with like lots of millions of rows. It uses the same process or the framework behind the scenes, like the queue-based framework, and it does the same concepts like dequeuing, and then it is all the flow controls and everything. But it is also an asynchronous process. So that's the reason why I have bulk load API as my separate slide. So enough of my theory. Now let's jump into knowing how to build this. So with that, I would like to turn over to MJ.
Thank you, Kartik. Very interesting to know what happens behind the scenes, under the covers in Salesforce. Well, good morning, good afternoon, good evening, everyone. Now that you've seen from Kartik the what and the why of asynchronous processing, let's take a look at the how. That is, what are the different ways in which we can launch Apex jobs? There are 4 different ways that you can launch asynchronous Apex jobs in Salesforce, using future methods, Queueable Classes, Batch Apex Classes, and Schedulable Classes. There's actually a fifth way using the system.continuation class, but since that only works in conjunction with Visualforce, we'll set that one aside and save it for a later time. Now, before we look at code, I'd like to look at a sample use case. And all of the code that we talk about today will be related to that sample use case. I should also say that all of the code that we're going to be looking at today will be available in GitHub, so you'll have access to it after the webinar. But here's our scenario. Our goal is to populate the account's billing longitude and latitude based on the billing address. This is a requirement that we as developers have been given, and we have to find a way to meet that requirement. Let's assume that somebody has given us a method that calls out to a web service and returns the longitude and latitude for a given account. So this has already been written for us. We don't have to worry about solving that problem. The method is in a geocoding utils class, and it's very simple to call the method. It's a static method. It returns an Apex class that has the longitude and latitude. It's called geocode account, and you hand it a single account. When you call this method, it calls out to a web service and returns the longitude and latitude to you. So you look at this and you look at this scenario and you say, well, clearly the answer to this problem is to write a trigger. We write a trigger that fires whenever an account is touched in a way that impacts its address. And when that trigger is called, when it fires, it calls our helper class. The helper class calls out to the web service. The web service returns the longitude and latitude, and we update the account with that information. Problem solved, right? Unfortunately, it's not quite that easy. The problem is that you cannot call out to a web service directly from a trigger. Triggers are supposed to be short-running operations, and callouts can be long-running operations. So Salesforce does not allow us to do a callout from a trigger. So instead, we're going to have to call out using an asynchronous process. The way that most people solve this problem is using the first technique Salesforce ever gave us for launching asynchronous methods, and that's a future method. A future method is a set it or forget it kind of method. Whenever code calls a future method, an asynchronous job is added to the job queue, and that's the end of the story. There's no way to monitor the status of the job. You can't chain future methods. One future method cannot call another future method. To create a future method, you write a public static method, could be global, but it's public or global and also static. And that method has to start with the declaration @future. The method returns void because after all, there's really nobody to return anything to. And the method can accept arguments, but only arguments of a limited type. It can accept primitives, things like IDs, integers, or strings. And it can accept collections of primitives, lists, maps, or sets. But the future method cannot accept S objects or Apex objects. If you really need to pass those into a future method, you can serialize them to a string, pass the string into the method, and then have the future method deserialize the string and reconstitute the objects you were trying to pass in. So here's what a future method looks like. I've got a public class that's got my future method in it, and here's the future method itself. Notice that before the definition of my method, I'm decorating it with @future, and then because my future method is calling a helper method that does a call out to a web service, I've had to add call out equals true. Then I have a public static method that returns nothing. It accepts a simple type of a parameter, an account ID. And when the method is called, it does a quick query. It just gets the account whose ID we were handed. It calls our helper method, handing it the account. It gets back an object that has the coordinates, and it updates the account with that information. One thing I should point out here, and it really applies throughout all of the code we're going to be looking at today, is that I really have not included any error handling here. This code is doing a simple update and a simple query up above. Really, we should be putting some error handling around that just in case there is a problem. because if there is a problem and this transaction fails, there's no way to report information about that back to the caller. There's no user interface associated with a future method. But for the sake of simplicity, I've left the error handling out for now. So here we have our future method, and it's pretty straightforward. Give it an account ID, and it's going to update the account. Let's take a look at the trigger that actually calls this method. Here's our account trigger, and it's really pretty straightforward. Whenever it iterates over the accounts, and whenever an account is touched in a way that causes its address to need to be geocoded, we just call our future method. It's just a straight call to the static method passing in the account ID. When we call it, that future method is put onto the queue. It's handed the account ID. When it executes, it does the logic we saw just a couple of minutes ago. So this looks all pretty straightforward. We've got a future method that does the geocoding. We've got a trigger that calls the future method. Problem solved, right? Not so fast. Unfortunately, we have a few problems. First, this trigger is not bulkified. And that's not a problem if somebody's updating a single account's address in the user interface. But if somebody does a data load and updates a whole bunch of accounts, we definitely have a problem, because Salesforce has a limit of 50 method invocations per transaction. Well, one alternative to this design might be to design our future method so that it accepts a list of account IDs instead of just a single account ID. But there's a limit to the number of web service callouts we can make in a single transaction. So if we hand the future method more than 100 account IDs, it's going to get into trouble. I should say, Salesforce has a pilot implementation in place right now that allows us to increase one of several limits that could impact future jobs. So you can increase limits for things like heap size, CPU time, number of SOQL queries, number of DML statements, or number of DML records. But none of those pertain to the number of web service callouts we can make, so that doesn't really help us in this scenario. Another issue with this design is that there's no way to monitor our future jobs once we've launched them. They go into the queue, and we can look at them through a monitoring page in the Salesforce user interface, but we can't write any code to monitor those jobs or to abort them. So unfortunately, this is not a great solution for us. What's a developer to do? Fortunately, we have an alternative. That alternative is the newest technique that Salesforce has given us for launching asynchronous jobs. That's the Queueable Class. A Queueable Class is like a future method in that it allows you to add a job to the queue to be executed. But unlike a future method, a queuable job can be monitored through code, and it can even be aborted. And a queuable job can call other queuable jobs, or even itself, so that a queuable job can be chainable. To create a queuable job, you create a public or global class that implements the queuable interface. Your class has to include an execute method that accepts a single parameter, a queuable context. And your execute method can use that queuable context to get the ID of the job as it's running. So you say, if the execute method accepts only one parameter, how do you pass information into it? Well, because the execute method is an instance method, it can access instance properties for the class. The execute method returns void because, just like with the future method, there's nobody to really return anything to. You can launch a queuable method, not just by calling the method, but by calling system.enqueueJob, handing it an instance of the class. And when you do that, system.enqueueJob gives you back an ID into the async apex job object. So you can use that ID to monitor the job over time. Here's what a queuable class looks like. It's a public class. It implements queuable. And because our execute method is going to be calling out to an external web service, we also have to implement database.allows callouts. We have an execute method that accepts a queuable context as an object, as an argument, and it's void. It returns void. It returns nothing. But note that our class also has an instance variable that contains a list of the accounts that we're going to update. The execute method begins by figuring out how many accounts it can process. And that may be limited by the number of callouts we're allowed to make per transaction. So we determine what's the maximum number of callouts we can make per transaction, what's the number of accounts we were handed with, and we are going to iterate over the minimum of that many accounts. So we loop over the accounts. For each account that we're going to process, we call our helper method, which geocodes it. We add that information to the object, and we add it to a list of accounts that we've processed. When we've processed as many accounts as we can handle in this single transaction, we update the list. And again, ideally, we do some better error handling here, but we'll save that for another time. We update our list to be processed, and then we remove the accounts that we processed from the list. And then, finally, we do something really interesting. If there are any accounts left on the list, we enqueue them into the queue again. So we launch another queuable job that is actually just this job's instance. We call system.enqueue job. We pass in the instance of this job, which has access to the instance variable, which is the list of accounts, and we get back another job ID, another ID into the async Apex jobs object. So you might be asking, if we're able to chain ourselves in a queuable job this way, why didn't we just chain the future job? Unfortunately, Salesforce doesn't let us chain future jobs, but queuable jobs are chainable. About chainable queuable jobs, I should mention one limitation. In developer and trial edition orgs, there is a limit to the depth of chained queuable jobs, but that's only in developer and trial editions. There's not a limit in both sandboxes and regular orgs. So that's our queuable job. Let's go back to our trigger. And our trigger for queuable jobs iterates over the accounts we were handed. For each account that has its address changed in an interesting way, we add that account to a list. And then when we're done building the list, if we have anything in it, we instantiate our Queueable class. We set its instance variable to match the list of accounts we just created. And then we call system.enqueue job. And system.enqueue job returns a job ID, which we can use to monitor the job in the async Apex job object. So this looks like a pretty good solution, right? We've got a Queueable class that's able to chain and call itself repeatedly. We've got an account trigger that will launch the process running. Everything looks pretty good, right? Well, unfortunately, there is a little bit of a problem. Salesforce currently has a known bug that prevents us from doing a web service callout from a chained queuable job. The bug is on Salesforce's known issue list, and we've got to believe it's being worked on. But right now, it impacts our ability to do web service callouts from a chained queuable job. Chained queuable jobs are still useful, and they still work in a lot of other cases, just not for web service callouts. So for our current use case, while a chained queuable job works brilliantly if we have a limited number of accounts to geocode, if we have so many accounts that we have to enqueue a chained job, the chained job is going to fail. So we're back to our question, what's a developer to do? Fortunately, we have another option, and that's using a batchable class. Batchable classes were designed specifically for situations where you have so much data to process or so much work to do that you might hit governor limits. Batchable classes come in three parts. They have a start method, an execute method, and a finish method. In the start method, you identify all of the records you want to process. Yep. Back up here. You identify all of the methods that you want to, all the records that you want to process. And that could be way more records than Salesforce would ordinarily allow you to process in a single transaction. After the system calls the start method and it gets a list of the records you want to process, it splits those records up into a number of smaller lists, and then it repeatedly calls the execute method over and over again with each one of those subsets of records. So the execute method might run multiple times, but when the last invocation of the execute method is finished, the system calls the finish method, and the finish method does some post-job wrap-up work. One of the great things about batchable classes is, like queuable classes, they can be monitored, and they can also be aborted if you decide you want to stop it midstream. The way you create a batchable class is like this. You create a global class that implements the database.batchable interface. As a result of implementing that interface, your class has to contain 3 methods. The start method that identifies the records to be processed, that's called the scope. And notice that the start method doesn't actually query to get the records, but instead it builds a query locator that identifies the records to process without actually fetching them from the database. More on that in just a sec. Second, you have to implement an execute method. The execute method is called by Salesforce repeatedly, each time with a different subset of the records that your start method identified. When you launch a batchable job, you could specify how large that subset of records should be. And because your execute method is called with a limited number of records, you can control how much work it does in any one invocation, which makes it much less likely that you'll hit governor limits. And finally, you have to write a finish method, which Salesforce calls after all of the records you identified have been processed. We'll look at an example in just a sec, but I want to mention a few other interfaces that you can add to your class. Database.stateful allows you to say that any instance variables in your class should be remembered between calls to the start, execute, and finish methods in the same job. So your class might have an instance variable that counts the number of records that the execute method processes, and each invocation of the execute method could bump that count. But if your class doesn't include database.stateful, that count won't be remembered from one execute method invocation to the next. The other interface that's useful, especially in our use case, is database.allows callouts. You need to add that if you're going to be calling out to a web service from within the batchable job. Now, you launch a batchable job by running the line database.executeBatch, handing it an instance of the class, and an optional second parameter. That optional second parameter is the number of records that each invocation of the execute method should be called with. The default number of records, the default scope size, is 200. You can set it to whatever you want, but the maximum scope size is 2,000. Just like when you queue up a queuable job, when you launch a batchable job, you get back an async apex job ID, which you can use to query the async apex job object so you can monitor your batchable job or even abort it. So let's take a look at the code. We have a batchable class. It's a global class that implements database.batchable, and we've indicated that we're going to be working with S objects. It's possible to have a batchable class that also works with an iterable instead of an S object, but virtually all of the batchable jobs I've written over the last several years have been with S objects, not so much with iterables. We've also added database.allows callouts because we know we're going to be doing a callout to a web service. And finally, we've added database.stateful so that any instance variables used by this class can be remembered between invocations of the job's methods. We define an instance variable, number of accounts updated, and we start it out at 0. And then we have a start method. The start method accepts a parameter. In fact, all 3 of the methods for batch job accept the parameter of a batchable context. You can use the batchable context from within the job to get the ID of the job as it's running. And then the start method says, I'm going to construct a query as a string. We're not actually executing the query, but we're defining a query as a string that says, get the IDs of all accounts where a need to geocode flag has been set to true. We'll worry about how that flag gets set to true in a few minutes. So we define this query, but instead of executing the query, we say database.getQueryLocator, and we give it the string containing the query. If we had actually executed this query, we would be subject to the limit of the number of records you can retrieve through SOCL queries in a single transaction. But by doing database.getQueryLocator, we're not actually fetching the records from the database, we're just identifying them. And a query locator can identify way more records than you can actually query in a single transaction. The limit for a query locator is up to 50 million records. So our start method returns a query locator that identifies all the records we want to process. So that's our start method. Here's our execute method. The execute method accepts a batchable context and also a list of S objects that is a subset of the S objects that were identified earlier. For that list of S objects, we query to get those accounts. We iterate over the accounts. We call our helper method, which calls out to the web service. We get the longitude and latitude, add it to the account, and then we set the need to geocode flag to false so we can use that flag again in the future. After we've completed all of that, we update the accounts, and we also bump the number of accounts that we've updated, so we'll know at the end of the job how many we've actually updated. Now, I mentioned earlier, and I want to mention again, that for simplicity's sake, I've left out the error handling. Here and everywhere in this code, we should be careful about error handling. The best practice is to call database.update, passing in the list and also passing in an all or nothing equals false flag. If we do that, we'll get back a list of save results, and we can iterate over the save results to determine whether there were any errors. If we don't do that, if we just call update as we're doing here, if any one of those accounts has an error, the entire update statement, and in fact the entire invocation of this execute method, will fail and none of those accounts will be updated. So that's our execute method. And finally, we have a finish method. It also accepts a batchable context, and we could do some cleanup work here. We could send an email to someone to let them know what's happened. Right now, we're just dumping out to the debug log the number of accounts that we've actually updated. The beauty of a batchable job is that it gives us a framework that allows us to process way more records than we ordinarily could process in a single transaction. And like a queuable job, and unlike a future job, a batchable job can be monitored. So you can write code that determines if the job you launched earlier is still running, or even abort that job. So just to finish the story on the batchable code, let's take a quick look at the account trigger. The account trigger says whenever an account is updated in a way that impacts its address, just set the need to geocode flag to true. When our batch job runs, it will find all of the records that have needs to geocode set to true, and it will process them. So let's actually take a look at that. Let's run this in this batch job and see what happens. I've got some execute anonymous code here, and it's going to cheat a little bit. It's going to go through all of our accounts and update them to set all of their needs to geocode flag to true. Then we're going to instantiate the batch job, and we're going to call database.executeBatch. We'll pass in an instance of the class, and I'm going to pass in a deliberately small scope size of 5, which means that our execute method will be called repeatedly, each time being handed 5 accounts that it has to process. The reason I'm keeping this number so small is that I want this batch job to take some time, because I want to be able to show you how we can monitor the progress of a batch job. So I haven't hit execute yet. I'm going to flip over here, look at our Apex jobs object, and let me just refresh that. There's nothing in there now. I come back and I'm going to hit execute, and right after I hit execute and it enqueues our batch job, I'm going to flip back over to where I can look at our Apex jobs. So I click execute, I keep my fingers crossed. It's enqueued our batch job, and now I come back here and let me reload the page. And I can see our batch job is processing. There are a total of 63 batches, which means there's something like 5 times 63 accounts that need to be updated. The last batch may have fewer than 5. When I refreshed, there were only 14 batches that had been processed. Oh, and now all 63 have been processed, and the status is completed. So through the user interface, you can monitor the status of your batch Apex jobs, or for that matter, your queuable jobs. And because both batch Apex and queuable jobs give you back IDs into the async Apex jobs object, you can also monitor them through code. But now you ask yourself, how do I get my batch job to run automatically? Running it through an execute anonymous page is fine, but that doesn't really solve our use case. Well, fortunately, Salesforce gives us a way to schedule jobs, and that's the fourth way of launching an asynchronous job. That's through the schedulable class. A schedulable class is a class that can be scheduled to run either once at a specific date and time or repeatedly according to a schedule that you define. And schedulable jobs are monitorable, and they can also be aborted. They can also be removed from the queue. To create a schedulable class, it's actually very simple. You create a global class that implements the schedulable interface. Your class includes an execute method that accepts one argument, a schedulable context, and you can use the schedulable context object to get the ID of your scheduled job in the cron trigger object. So it's fairly simple to write a schedulable class. Let's take a look at one. Here's a schedulable class. It's a global class. It implements schedulable. It has an execute method that returns nothing and takes a schedulable context as an argument. And all our execute method has to do is launch our geocoding batch job. When we launch the job, we actually figure out what's the maximum number of records that a batch job can accept, what's the maximum number of callouts that a single invocation of the batch job's execute method could do. We take the minimum of that, and that's going to be our batch size, our scope size. Then we instantiate the batchable job, and we call database.execute batch, handing it the class and handing it the batch size. So when this runs, it will launch, when this runs, it will launch our batchable job, and the batchable job will geocode all the records that the account trigger flagged. But the next question now is, how do we get the schedulable job onto the schedule? Well, there are several ways we can do that. We can do it through the regular Salesforce user interface, but we can also schedule a job through code by calling system.schedule. When you call system.schedule, you give it a unique job name, a cron expression, which I'll come back to in a sec, and an instance of the class that you want to schedule. When you call system.schedule, you get back a cron trigger ID. So that's an ID that you can use to query the cron trigger object to see what your job looks like on the schedule. Now, cron expressions can be fairly complex. Really, the best way to learn about them is to play with them and to check out the Apex language reference for all of the gory details. But a cron expression is a string that contains all of the tokens you see here on the slide. Let's walk through a couple of examples to make that a little bit more real. Let's say that we wanted to run our geocoding job at 30 minutes past midnight on January 1st of every year. We would instantiate our schedulable class. We would then call system.schedule, passing in a unique job ID, a job name, an instance of the class, and a cron expression that looks like this. The way to read this, keep an eye on these tokens across the top. The way to read this is to say at 0 seconds and 30 minutes after the 0th hour, that would be midnight, on the first day of the first month, on the first day of the first month, I don't care about the day of the week, of every year. That's when we want this to run. Let's look at another example. In this particular case, we want our geocoded class to run hourly. So we would instantiate the class, and then we would call system.schedule, give it a unique job name, and then a cron expression that we read by saying at the 0th second of the 0th minute of every hour of every day of the month, of every month of the year, I don't care about the day of the week, for every single year. So that's a cron expression that will run the job at every single hour. Let's look at what happens when we actually run that. So I'm going to start under Setup, Jobs, Scheduled Jobs, and I'll refresh this just to prove that there's nothing on the queue. Come back to my console here. And I've got some code here, which I'm going to highlight in just a second to run it. I instantiate my schedulable class, and I'm going to call system.schedule with that cron expression string that I just added. So I'll highlight that and say execute highlighted. And it executed that, and with any luck, it has added it to our scheduled job queue. So I can see, here's my job name, and it's scheduled to run in just a few minutes at 2 o'clock Eastern Time. Now, cron expressions really can get very complex, so I encourage you to look at the Apex language reference for details. If the requirements that you have for when your job should run are not as complex, you can actually schedule a job directly through the user interface. You go to Setup, Develop, Apex Classes, click Scheduled Apex, you give it a job name, you pick the class that you want to run, and then you can use this user interface to decide how often your job should run. But the options on this page are a little bit limited. It won't allow us, for example, to schedule a job to run every single hour. So although it takes a little bit of work to get used to cron expressions, it's well worth the investment. Well, we have walked through a lot in our whirlwind tour of asynchronous Apex. Let's do a quick review. Asynchronous jobs are useful when there's something that you either can't do in the context of your original transaction, like calling out to a web service from a trigger or doing a mixed DML operation. And they're also useful when you don't want to wait for longer running transactions to finish. There are 4 main ways in Apex to create asynchronous jobs. It's a future method, which is good for quick set it and forget it launching of an asynchronous job, but there's a limited type of arguments you can pass in. You can't monitor a future job and you can't chain a future job. Queueable classes are a more grown-up way of running asynchronous jobs. They can accept more complex arguments that are handled as instance variables of the queueable class. You can monitor and even abort queueable jobs, and you can chain them, although there's currently a bug that prevents chaining a web service callout when you need to do that in a chained queueable job. Batch Apex is definitely the way to go when you've got large numbers of records to process, or when you need to do more work than Salesforce would normally let you do in a single transaction. And finally, Schedulable Apex allows you to place a job on the queue so that it can be run at a later time. There's a lot more that we could cover here, but we're getting to be a little short on time, and I want to make sure we have some time for questions. So I'd like to encourage you to check out the Apex language reference for details on how to monitor jobs and how to test them. And also check out the code in GitHub for everything you've seen today, plus samples of unit tests. Now, before we move on to questions, let's do a quick recap. Kartik talked about asynchronous processing in general. He talked about how the Force.com platform adds jobs to the asynchronous queue, and especially how the platform decides which jobs to pull from the queue and when. He also talked about the advantages of using asynchronous processes, like how they're useful for avoiding governor limits, mixed DML errors, and issues with making a call out from a trigger. And finally, I took you on a whirlwind tour of the 4 main ways of launching asynchronous Apex jobs: future methods, queueable classes, batchable classes, and schedulable classes. There are a lot of resources that you can check out to learn more about what we've talked about today. And of course, there's Trailhead. There's an entire Trailhead module dedicated to asynchronous Apex with challenges that encourage you to write your own asynchronous Apex code, and you even get a badge for doing that. With that, let's move on to some questions.
Thank you, MJ. So we're running a little short on time, so we'll probably take like 2 more questions. And what we'll do is we'll answer all your questions on the FAQ page on the webinar recording link. So you'll be getting the recording link with the slides, a PDF of the slides, and also the link to the code that you just saw in the webinar. And you can refer to it anytime. So let's take a couple of questions before we end our webinar. So there was a question on: is the default batch size of 200 a fixed number, or does Salesforce optimizes and tries to process more records per batch? Do you want to answer that, MJ?
That's a really interesting question. It is a fixed number. So by default, if you do not specify a scope size of 200 is always used. But that's why it's useful to actually specify the scope size yourself so you can control how much work happens in that execute method.
So the next question is more on the queue store. So there is a question asking, where is queue store? So it is not on your Salesforce instance. So it is on the cloud. It is on the Salesforce servers where the whole queue-based framework is done. So the queue store is, yes, it is on the Salesforce servers. So there's a very interesting question on, is it safe to pass collection of S objects into queuable instead of collection of IDs? Objects may change, so the criteria may return different records.
That's exactly true. And in fact, if you go back when you get into GitHub and you look at the code that I wrote, you'll notice that the queuable method actually, let's see, let's pull that up. Our queuable method, we're handing it through the trigger. If we're doing a queuable method, we're not handing it the entire account record, we're handing it just the billing information. Now there's a theory that yes, we should just pass in the account IDs and not the billing information, and we could do that, but if the billing information were to change again, then another job would get added to the queue, or the trigger would fire again, and it would create another queuable class instance. So yes, in general, it should be handled the way that the batch job handled it, where the execute method actually queries to get the details of each account. In this particular case, if somebody changes an account's billing address twice, then 2 jobs will get queued that would have gotten queued anyway, and each job will process the address that it's been given.
That's very good explanation. Thank you, MJ. So the next question is, do all the requests synchronous and asynchronous go through this queue framework? No, it's only the asynchronous requests that go through the queue framework. There are close to 2,000 types of asynchronous requests. We might have only 4 or 5 that we actually write, but there are some internal asynchronous processes as well that Salesforce runs behind the scenes. And all these asynchronous processes go through the queue framework. But the synchronous ones, no, they have a different process. So there are a lot of questions on, please share the code somewhere. We do have the code on the GitHub, and you will be getting the URL to the code, and you can access the GitHub. You can download the code, and you can play around as well. So if I'm not able to answer any of your questions, we'll definitely get back to you with the responses, and look out for the FAQ page on the webinar now that it's top of the hour. So thank you all for joining this webinar, and thank you very much. And there is also a feedback link, bit.ly advanced apex. So your feedback is very crucial to us on the success of the webinars, and we'll talk to you soon. Thank you.
Thank you, and have a great rest of the day.